Hi grade 10s, this is JP, and today we're going to look at another aspect of trigonometry, special angles, and then I just want to mention or make mention of similarity and why that's such an important concept in trigonometry. Let's look at similarity. So when two triangles are similar to each other, that means the corresponding angle, the angles in the triangle are exactly the same, but the lengths are, it's multiplied by a scale factor. So as you can see there, that little triangle there, ABC, right, fits into there, and then there's another triangle in there, the big one, ADE. What you notice, of course, is that angle A, right, in the small triangle is the same as angle A in the big triangle, right? That's a common angle there. And what you will also notice is that angle B in the small one, right, is equal to angle D in the big one, right? The simple reason just for that is, of course, if angle ACB and CED are both 90 degrees, that means those two lines are actually parallel to each other. And then those two triangles can fit into each other's corresponding angles. Right, so that's the first part. So these two triangles, and then of course the third angles are 90 degrees. So so these triangles are similar because they have of course got three angles, and those three angles are the right angles are equal to each other. And then, of course, the lengths are multiples of each other, or factors of each other. So you'll notice that the small AC is equal to 3, and the big one is double 3, right? 3 plus by 3. So that's equal to 6. And then we've got BC that's equal to 4, and then we've got DE that's double 4. And then last part is we've got AB that's 5, and we've got AC that's double 5. All right, you would think, just get to your point. What are you saying here? So what I'm saying is the following. So when I would work out here sine of A, okay, if this is my reference angle, angle A here, that is going to equal to 4 over 5, right? The opposite over the hypotenuse. So, and cos of A there is going to equal to 3 over 5, right? The adjacent over the hypotenuse, and tan of A is going to equal to opposite over adjacent, so which is 4 over 3. Then what we've got is if I work in the big triangle there, and so let's make this our reference angle there, just for now. So what do we have there? We've got sine of A there is going to equal to, so that's opposite, right? That's adjacent, that's hypotenuse. Sine of A is equal to 8 over 10, and 8 over 10 can be simplified as 4 over 5, and which is exactly the same as the ratio in the small triangle, right? And cos of A is equal to adjacent over hypotenuse 6 over 10, which can be simplified to 3 over 5. And then tan of A is equal to 8 over 6, which can be simplified as 4 over 3. So do you see those, of course, they all correspond, or they're exactly the same ratios. So if we think about it in this way, so imagine we've got two triangles, okay? So the only thing is the lengths of sides are different. So angle A is still 30, and angle C is equal to 16, both triangles. So what we've got, if I give you the length of two sides, so 5 for example, and the other one is 10, then you can use Pythagoras to calculate, well, that will be equal to the root of 75, right? 100 square minus 5 square is equal to 75, and then the square root of it. But say, for example, we double the length of one side. So say, for example, BC we double in this one, or let's triple it. Let's go wild. So that is 15. Then, of course, AC now is going to equal to 30. We double it. And what's going to happen to AB then? Remember, these triangles are similar. The ratios must still be the same, right? So then you'll need to triple that one as well. So it's 3 times by the root of 75. And there we go, 3 times the root of 75. Okay, it's because the ratios must be the same. In other words, sine of 30 in this triangle must be 5/10, right, which is equal to half. Sine of 30 in that triangle, well, must be the same thing, right? Sine of 30 must have the same ratio, which then is equal to 15/30, and which is also equal to a half. Okay, hopefully you understand that triangles, similar triangles, of course, must have the same ratios in 90-degree triangles. Very important part there. Okay, so let's look at activity 3 now of the attachment you've got from yesterday's lesson. So by now you've completed activity 1, you've completed activity 2, and you've marked your solutions, right? You need to do all of this before the following will make any sense. Okay, so let's go for it. So there's essentially 5 special angles, but we're going to look at 3 of them now. The 0 and 90-degree special angles will make sense when we do trig graphs. But we're going to look at 30 degrees, 60 degrees, and 45 degrees special angles. Okay, so this is quite fun. So remember back in the day, Casio didn't quite exist when the Greeks and the Babylonians played around with trigonometry, right? So this was such an important discovery when they realized, oh, there's something quite unique about 30, 60, and 45, and it's actually so simple. So let's trace back what happened. So if you would draw a square, right, we're all boxed in, so we will relate to a square. So if we draw a square and we make one of each of the sides 1 unit, right, 1 unit, and then we draw a diagonal. So it's a square, so each of the angles is 90. So what will the length of the diagonal be? Well, we'll say it's the sum of the 2 short sides is equal to the diagonal square. So in other words, the square of 1 is 1, plus 1 is equal to diagonal square. So 2 is equal to the diagonal square, so the diagonal is equal to the root of 2. So that part there is actually the root of 2. What's all those angles now equal to? Yeah, so remember, so it's each of the angles in the square, of course, must be 90 degrees. So the diagonal there would bisect that angle. It's one of the properties of a square. So that will also be 45 degrees there, right? So what we're now going to focus is this red isosceles triangle. Beautiful isosceles triangle with 2 45-degree angles, of course, and then each of the sides is 1. So what do we notice? Okay, so remember, triangles that's similar will still have, in a 90-degree triangle, will have those same ratios. We're only busy dealing with 90-degree triangles now. So let's go for it. So sine of 45 degrees. What was sine of 45 degrees? Well, if I make this angle here, this 45 degrees, it doesn't matter which one. Let's make that sine of 45 degrees my reference angle. So the ratio of sine is opposite of hypotenuse. So then this is adjacent, and that is opposite, and that's hypotenuse. So sine of 45 degrees is going to equal to 1 over the root of 2. All right? And what we've got is, we've got cos of 45 degrees, which is equal to adjacent over hypotenuse, and that's 1 over the root of 2. And then we've got tan of 45 degrees, which is opposite over adjacent, so opposite over adjacent, which is 1 over 1. And remember, in a square, those lengths will always be the same. So therefore, that is going to be just 1, right? And we're going to do a bit of rationalizing denominators a bit later. 1 over the root of 2 is exactly the same as root 2 over 2. You can check that on your calculator. Another lesson will take place later. We'll talk you through that. Okay, so 45-degree angles are very easy to compute, right? Tan of 45 is 1. And tan of 45, just by the way, so that kind of lets us, tan is, in this sense, okay, so opposite of adjacent. So it's almost like the rise over the run. It's almost like the gradient here, right? So the gradient there is equal to 1 in a square, of course. Maybe just something to think about. We'll look at that a bit later. Let's look now at the 30-degree and 60-degree angle. So what we've got here is to ask you to draw equilateral triangle. Equilateral triangle is what again? Yeah, it's a triangle where all the sides have the same length, right? And I say Draw equilateral triangle with all the sides with a length of 2 units. Okay, and then draw a perpendicular bisector. So what the heck is that? So it means it goes from one vertex and it divides one of the sides into two parts, two equal parts, right? So in other words, that angle there would be 90 degrees. And if the length of the whole thing is 2, that whole side is 2, then of course, and it's a perpendicular bisector, so then the length of each of those parts must be 1. All right, and then what we can do is we can find, so what we're going to do is we're going to work in one of these triangles. It doesn't matter which one. Okay, and so what we've got is this is a 60-degree angle, that's a 60-degree angle. The top angle is now divided into two parts, so that's 30 degrees and 30 degrees. Hopefully that makes sense. And we can find the missing side, length of a side there by using Pythagoras. So in other words, what we can do is we can say it's the short side square plus, I don't know, let's call this x just for now. X squared is equal to 2 squared. So x squared is going to equal to, so it's 1 plus x squared is equal to 4. X squared is equal to minus 1 on both sides, so it's 3. So x is equal to the root of 3. So it's actually plus or minus root of 3, but it won't make sense in this context for x to be negative, right? So negative length would be a bit strange. So so here we go. So that part then is the root of 3. That's not too bad, eh? In other words, can we work out what the ratio of sine of 30 and sine of 60 is, and the ratio of cos of 30 and cos of 60, and tan of 30 and tan of 60? I know, let's give it a go. So sine of 30 degrees is going to equal to, so if this is my reference angle 30 degrees, it's going to equal to opposite of our hypotenuse, so that is equal to, that's the opposite, right? And then that's going to be the hypotenuse, so that's going to be 1 over 2. And cos of 30 degrees is going to equal to the adjacent over the hypotenuse, which is equal to root 3 over 2. And then we've got tan of 30, which is equal to opposite over adjacent, so that's going to equal to 1 over the root 3. And just by the way, 1 over the root 3 is the same as root 3 over 3. You can just check it out on your calculator as well. And then the other part, what we're going to do is we're going to look at if 60 degrees was my reference angle. So in other words, we've got sine of 60 degrees. Sine of 60 degrees is going to equal to, so it's the opposite, which is the root of 3, over the hypotenuse, which is 2. And we've got cos of 60, which is equal to the adjacent now. Remember, this is now adjacent, that is opposite, and that's hypotenuse, if my reference angle change. So it's adjacent over the hypotenuse, which is equal to 1 over 2, a half. And then tan of 60 is going to equal to opposite of adjacent, which is root 3 over 1, which is just root 3. Okay, I want you to see something quickly. This is so beautiful, it's going to blow you away. So what did we say was the big difference between sine and cos again? The ratios of sine and cos. So sine of a reference angle, right, is equal to the opposite over the hypotenuse, and cos of a reference angle is equal to adjacent over the hypotenuse. So what's the only difference? Well, the opposite and adjacent, they need to switch around, right? That's the big difference. Okay, so but what is the effect of what does the opposite and adjacent do in a triangle? You know, so what is the case there? So so I want to show you something now quickly. Cos of 30 is equal to root 3 over 2. Sine of 60 is equal to root 3 over 2. In other words, 30 degrees plus by 6, oh, that's not effective at all. So 30 degrees there plus by 60 degrees. What is that equal to? Yeah, it's 90, right? The second observation I want you to make is sine of 30 is a half. That's exactly the same as cos of 60. What do we notice about those? Oh, that's not that. But 30 degrees plus 60 degrees, that's equal to 90 degrees. Okay? So in other words, sine of an angle, right? So say for example, sine, ooh, can't see that. So sine of 5 degrees must be the same as what? Well, sine of, if the one is sine of 30, is exactly the same as cos of 60, okay? And cos of 30 is the same as sine of 60. So sine of 5 degrees must be the same as cos of 85. Hopefully that makes sense. The sum of those angles, if the sum of those angles add up to 90, right, then those ratios must be the same. So sine of an angle, so sine of A, for example, must be the same as cos of 90 minus A, if that makes sense. And cos of A is equal to sine of 90 minus A. All right? Okay, so you think, so what? So you've got those special ratios. Why is that important? Okay, so $100 and a high five. So if you can construct the following triangle. So in other words, 30 and 60 degrees, and then the length of one must be 3 centimeters. The length of the other side between the 90 and the 60 degree angle must be 4 centimeters, and the other one must be 5 centimeters. Show me if you can sketch it. I'll place a lot on the bed. That triangle, you are not possible to sketch that. I know your mom has been telling you, you know, just keep on working hard, my child. You'll do anything. Well, she lied to you. You cannot, even if you work very, very hard, you cannot construct that triangle with those dimensions and those angles on a 2D surface. Maybe on some other strange surfaces, but you cannot do that. It's impossible. It's not difficult. It's impossible. Why? Let's prove this mathematically. So if I've got sine of 30 degrees is supposed to, we've seen from the previous exercise, that it's supposed to equal to a half. Okay, just rewind if you forgot that. Sine of 30 degrees is equal to a half. And sine of 30 degrees is exactly the same as cos of 60 degrees. Cos of 60 degrees is also a half. And what we know is we've got sine of 60 degrees. Sine of 60 degrees is equal to root 3 over 2. And that, of course, is the same as cos of 30 degrees. That's also equal to root 3 over 2. So, you know what's very cool about this? If you know 1, if you know sine of 30, you know cos of 60. Remember, as long as those angles add up to 90. If you know sine of 60, you know cos of 30. And then sine of 45 degrees, remember we said it's root 2 over 2, which is the same as root 1 over 2. Well, 45 plus what is 45? That must be the same as cos of 45. Sine of 45 and cos of 45 is exactly the same. Isn't that beautiful? Okay. And then, okay, so that's the relationship between sine and cos, because of course, remember, they're adjacent sides. Okay, so let's look at this. But the thing is now, sine of 30 degrees is supposed to be a half. But in this triangle, sine of 30 degrees is what here? Sine of 30 degrees is 4 over 5. 4 over 5 is not equal to a half, right? No ways, Jose. That's why this is not right. I mean, this triangle, impossible to draw. All right. So this is quite neat. Now we're going to look at finding finding the length of a missing side. Dory is found. I mean, we don't need to stress about him. So now we're going to look at finding the length of a missing side. And we're only going to look at special angles. Okay, so let's look at the missing side. So in the first example, I'm going to do 2 examples at the same time. Hopefully this will give you a good idea what's going on. So in the first example here, we've got an angle of 30 degrees. That would, of course, mean that angle is 60. And so if this is my reference angle I'm going to use, this is my adjacent side, that's my opposite side, and that's my hypotenuse side. Okay, so the first thing you're going to do is if you've been presented with an angle, which we have, and so that one, and you've been presented with a side, which we have 5. Okay, you look at, what do I now need? I need to find the length of another side, right? So I need to find the length of x here. So the 2 sides in question, remember, the trick we're doing now It's the ratios, there's the relationships between the angles and the sides, right? So I've got the relationship between the sides, so it's that one, that x, and it is 5, right? And so what function deals with opposite and hypotenuse? Which function is that going to be? So that, of course, will be sine. So sine of 30 degrees is equal to opposite. Sine of any angle, right, is opposite of hypotenuse. And what is the opposite angle there equal to? It is 5. And what is the hypotenuse there equal to? It's x. It's an unknown. All right? So I'm just going to leave that there for now. Let's look at the one on the right-hand side there. So here we've got an angle of 30 degrees again. So we've got an angle. Again, so this is my adjacent, that's my opposite, and that's my hypotenuse. So we've got opposite and hypotenuse. So what function is that again? It's again sine. So sine of 30 degrees is equal to opposite, which is x, over the hypotenuse, which is 5. Okay. So now the next part is, what is sine of 30? We know the special angle. We just did it earlier. What is sine of 30? Well, that is equal to a half, all right? So a half is equal to 5 over x. The same in the other triangle. In other words, a half is equal to x over 5, right? You understand where sine of 30 comes from, right? Just rewind. So, and now in each of those, we need to solve for x. Okay, find the missing side, x is the missing side. So, let's do the blue one first. How would we get x alone there? Well, x is divided by 5. So what is the opposite of dividing by 5? You times by 5, right? Times by 5 on both sides. So 5 times by a half is equal to x. And what is 5 times a half? 5 over 2, 2.5. Let's quickly check if that makes sense, if that is equal to 2.5. Remember what we said is, in sine of 30, the opposite side, right, must be half of the hypotenuse side, or the hypotenuse must be double. It's 1 over 2, right? The hypotenuse must be 2 times bigger than the opposite side. If the hypotenuse is 5, of course, then the opposite side must be half of that. So it's 5 over 2. Yippee yay! Okay, so let's look at the first triangle there. So we need to find x there. We've done equations last term, so this is going to be maybe a bit hectic for some of you. So 5 divided by x. So if x is on the denominator there, what's the easiest way to deal with it? Well, times by x on both sides, right? You times by x on the left-hand side, and you times by x on the right-hand side. And what is x times by 5 over x? That is equal to 5. And what is x times by a half? It is a half x, right? X over 2. X times by 1 over 2. And then how do I get rid of the 2 there? Well, you times by 2 on both sides. So 2 times by x over 2 is equal to 2 times by 5. Therefore, x is equal to 10. Okay, let's see if this makes sense. If this is 5, remember the ratio of sine of 30 must be a half. So opposite of hypotenuse must be a half, right? So if opposite is blur, the hypotenuse should be 2 blur, all right? So if that is 5, that part there would be 5 times by 2, and that is 10. Yippee yay. Okay, let's look at the next example. So here we've got, again, two 30-60 triangles. And in the first example, okay, so that's my reference angle. This is my adjacent, opposite, hypotenuse. Okay, so your first question is, okay, so which sides are going to be involved? Well, I want x, which is my adjacent, and I have 6, which is my hypotenuse. So which function deals with adjacent and hypotenuse? So adjacent over hypotenuse, okay, that is going to equal to cos, yes. And we don't want to use those reciprocal functions. I'll talk a bit later about them. But so cos of 30 then is equal to the adjacent over the hypotenuse, the ratio of the adjacent over hypotenuse. So cos of 30 there, what is the adjacent there? It's going to be x, and what's the hypotenuse? It's going to be 6. Okay, I want to solve for x, right? I'm looking for the missing side. So how do I get x alone there? So x divided by 6 is equal to cos of 30. We can just multiply 6 on both sides, right? Multiply 6 on both sides, and what happens then? We've got So 6 divided by 6, of course, is 1. That's why we multiply 6 on both sides. So 6 cos 30. And you just type that in your calculator. What is 6 cos 30? And just make sure your calculator's in degree mode. 6 cos 30, so it's 6 times by, and your calculator would tell you if you type that in, it's root 3 over 2 is cos of 30. So then that is x is equal to, and 6 times by root 3 over 2 is equal to 3 root 3. And if you press the S to D button, it's the one just above delete, and then you will get the decimals for that 3 root 3. What is 3 root 3? Let's just double check that. 3 root 3 is equal to, 3 root 3 is equal to 5 point, if you round off to 2 decimal places, it will be 5.20 because it's 19. Third one is greater than 5, so that's 5.20. Hopefully that makes sense. Let's look at the next one. So again, we've got an angle there. That's our reference angle. So that's my adjacent. That's opposite. That's hypotenuse. So again, the question you're asking is the relationship, the ratio of which sides. It's adjacent has been given and hypotenuse has been given, or is the one I need. All right. And then you've got your angle of 30 degrees. So which function works with adjacent and hypotenuse? Again, it's cos. So cos of theta is equal to adjacent over hypotenuse. In this case, my reference angle is 30 degrees. And that's very bad writing. So cos of 30 degrees is equal to adjacent, which is 6, and the hypotenuse, which is x. Okay, so how do I deal with this now? How do I get rid of the x on the denominator? Remember, you multiply by x to every single term. So it's x cos 30 degrees is equal to x times by 6 divided by x. And then on the right-hand side, then that will be equal to 6, right? X divided by x is 1. And on the left-hand side, we've got x cos of 30 degrees. And now we want to just have x alone. So how do I get rid of the times by cos 30? We divide by cos 30 on both sides. So x is then equal to 6 over cos of 30 degrees. So let's look at these two examples now. So we've done 4 up to now, so this will be 5 and 6. Okay, so let's go for it. So that's a 6. Quite a unique way of writing 6 sometimes. So let's go for it. So we've got the angle, that's my reference angle. So this again is my adjacent, my opposite, and my hypotenuse. Again, what's the first question you ask yourself? What's the relationship I'm looking at here? I've got the x I want, and I've got the opposite. So it's adjacent and opposite. What function works with adjacent and opposite? So that, of course, will be tan. So tan of 30 degrees is equal to opposite over adjacent. That's why it's so important to know those ratios, right? You don't have time to go or whatever those weird stuff is. You need to know opposite hypotenuse sine, adjacent over hypotenuse cos, opposite over adjacent tan. Okay, get it at 2. And so then tan of 30 degrees is equal to, and what is the opposite there? It's 6, and what is the adjacent there? It is equal to x. Okay, and the other triangle, let's go for it. So this is opposite, so that is, that's my reference angle, so that's opposite, and that is adjacent. Again, opposite adjacent, tan, baby. So tan of 30, that is equal to opposite of adjacent. Easiest way to get a tan in winter is to divide the opposite side divided by the adjacent. Yeah, okay. So tan of 30 degrees, tan of 30 degrees is opposite, which is x, and adjacent, which is 6. Okay, let's go for it. So they're almost the same, reciprocals of each other. So in the first one, how do I get rid of the divide by x? You would times by x on both sides, right? So tan of 30, and then what do I do? So then and then times by x on the left-hand side as well. So x tan of 30 is then equal to x divided by x is, of course, then equal to 1. So it's just 6 divided by 1 is 6. And then you divide by tan of 30 on both sides. So it's 6 divided by tan of 30. Okay, let's look at the right-hand side one. X divided by 6. I don't want x divided by 6. I want just x. Give it to me, x. So times by 6 on both sides. So 6 tan of 30 degrees. And you type those in your calculator. So if I type in my calculator, what is 6 divided by tan of 30 degrees? Tan of 30 degrees, just close the bracket there. It's going to equal to 6 root 3. And what is 6 root 3 equal to? You just press that S to D button. It's 10.40. Okay, and if you press on your calculator, you just type in what is 6 tan of 30 degrees. And that is 2 root 3. 2 root 3 is equal to x. And what is that as decimals? It's 3.46. 3.46. And there we go. All right, so those are your two solutions there. Okay, so let's do a mixed example, yeah? So we ask you to find, so I give you an angle, I give you one of the lengths, and to ask you to find two lengths, right? So, okay, so let's go for it. So what's quite cool here is, so you've got your reference angle, and you've got one side. So if that's my reference angle, again, that's adjacent, we've got opposite, and we've got hypotenuse. Okay, so it's up to you which one you want to find first, x or y. So if you want to find, say for example, x first, all right? So what we're going to deal now with is we're going to find cos of 30 degrees is equal to the adjacent over hypotenuse, which is equal to 8 over x. Do you follow? Adjacent over hypotenuse, cos, and then bang, bang. So therefore, then you multiply x on both sides. X cos 30 degrees is equal to 8. So therefore, x is equal to 8 divided by cos 30. If you didn't get that, just rewind a bit. So I explained it earlier. So what happens if x is on the denominator? Okay, so that's cool. Ne? So if you type that in your calculator, then x is kind of equal to, let's just do that quickly, sorry. It's 8 over cos of 30, and it is equal to 16 root 3 over 3. Very sexy. So, if you press the S to D button, that then is equal to 9.237, and blah, 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 goes on. Okay. Now, you've got two choices to work out y. You can either, again, I'm going to do both of these, you can either use one of the trig ratios to find y, or you can use Pythagoras, right? Because now you have x, and therefore you can just find the third side. You understand that? So if I would use it, so to find y, and the first one is to use a trig ratio, what you would do is, okay, so let's just erase the purplies. Right, and that as well. Okay, so I just messed up the triangle there. Okay, so what we've got is we've got my reference angle is still 30 degrees. I've got the adjacent side, and now I want to work out the opposite side. So opposite and adjacent, that is equal to what? Yeah, tan. So tan of 30 degrees is going to equal to tan of 30 degrees is going to equal to opposite over adjacent, so y over 8. So therefore, 8 tan of 30 degrees is going to equal to y. Okay, the same thing here. We don't needed a calculator here to do this. What was cos of 30 actually equal to? So that's root 3 over 2. Remember, cos of 30 degrees is equal to root 3 over 2. So yeah, I could have just gone, remember we had x is equal to 8 divided by cos 30, so that is root 3 over 2. And how do I divide fractions again? I've got 8 divided by root 3 over 2. That means it's 8 times by 2 over root 3, which is equal to 16 over root 3. Okay, and 16 over root 3 is exactly the same as 16 root 3 over 2 over 3. So it's just rationalizing to denominators. Okay, so the same thing here now. What is tan of 30 equal to again? Can you remember? Tan of 30, what is that equal to? Just look at your special angles if you don't know. So that was equal to that 1 over root 3. So 8 times by 1 over root 3, right, is equal to y. 1 over root 3, of course, is the same as root 3 over 3, right? and then we've got 8 over root 3 is equal to y. But say, for example, you didn't want to use trig ratios to work out y again. What did I do? You wanted to use Pythagoras, okay? Why not? So in other words, say, for example, you worked out x first, and you got that baby, or you got 16 over root 3 looks a bit better, okay? So we got x is equal to 16 over root 3, and we've got the other side, the length is 8, okay? So what we've got is the sum of the two short sides there, rather. It's sum of the two short sides square of a triangle is equal to the hypotenuse square. So, in other words, y square plus by 8 square is equal to x square. Y square, that's what we want to find out, plus 8 square is equal to x square, which is 16 over root 3 square. Okay? Ooh, see my power is a bit disempowered. So 8 square is equal to 64. And what is 16 over root 3 times by 16 over root 3? What is 16 times by 16? Hey, do you guys know what 16 times by 16? That is equal to 256 over 3. All right? So therefore, y square is equal to 256 over 3 minus 64. Okay? So y square is equal to, if you go 256 divided by 3, in this part you can do in your calculator. I don't mind too much, right? And you're finding the lowest common denominator and so on. So that then is equal to, I think it's going to equal to like 64 over 3, right? And then you just square root on both sides. So that's going to equal to the root of 64 over 3. And by the way, if you simplify that, it is equal to the root of 64. The numerator is 8 over root of 3. So it's just dealing a bit with surd, which is again exactly the same as what we've had earlier on for y, right? Those y values are the same. So it's up to you whether you want to deal with, you do it with Pythagoras or just to use a trig ratio again. So last example, I've got now again another 90-degree triangle with x, y, and 8. And what I've got is I've got the reference angle that is 60, so that's my adjacent, that is my opposite, that's my hypotenuse. And we've got, we want to find x or y first. So I'm going to do this one with using two trig ratios. So say, for example, I want to use x first, right? So that, therefore, it's going to be adjacent hypotenuse. So therefore, cos, adjacent hypotenuse, of course, is cos, right? So cos of 60 is equal to adjacent of hypotenuse, which is x over 8. How do I get x alone? I multiply 8 on both sides. 8 is equal to cos of 60 degrees is equal to 8, is equal to x. And what is cos of 60? If we ask you not to use a calculator for this, it means you must know those special angles. Cos of 60 is, of course, the same as sine of 30, which is equal to a half. And then what is 8 times by a half? That is equal to 4 units. If we want to work out y using that, okay, so let's have a look. So in other words, that's no longer the case. So I want to use the opposite and hypotenuse. Right, so opposite and hypotenuse. So opposite and hypotenuse, we're going to deal with sine then. So sine of 60 degrees, opposite, which is y, hypotenuse, which is 8. So 8 sine of 60 degrees is equal to y. So then y is equal to 8, and sine of 60 is root 3 over 2. So that is equal to 8 root 3 over 2 is equal to y. And 2 goes to himself once, and then 8 4 times. So 4 root 3 is equal to y. Okay. Hopefully this makes sense to you. I now want you to do the exercise in your textbook. That's got all of that. I think it's activity 4, right? Activity 4 I want you to do. And yeah, please make use of me. Ask me questions if I can clarify concepts. Thank you.